wait maybe more another 2 minutes or so. I think we'll get started. So if everyone can open the 2 links I've sent on the Warwick 118 Python channel. The first one is the one I have open, and this is where we have the content and exercises for the session. And the other one is like I'll release exercises throughout the session, and you can answer them live, just to make things a bit more interactive. So I'll release a test question to see if everything is working for everyone. Okay, so we have a few people who answered. And at the end of each question, I will reveal the answers, and I'll also go through them and explain why each option was right or wrong, so on. Still have a few people submitting answers. And if you have any questions, you can also ask on the Y118 channel, and I'll read the question, or you can unmute your microphone and ask. Okay, so I think most people have the website open, so I'll get started. So now it shows that the only 2 options were right. So today we'll be covering variables, operators, and functions. These will be the building blocks for the other session we'll run, and they will help you build a simulation. That's one of the objectives of this course. I'd also like to introduce myself. I'm Thomas. I'm the head of education at Warwick AI. And I'm basically responsible for helping organize the courses or create some materials. And I will be doing this first session and maybe a few others. So variables are like containers you can use to store values. And they can have different types. So you can think of it like a box that's labeled, and inside you can store different types of items. So today we'll be covering strings. So a string is a list of characters. So you can think of it as a sentence or a few words. And a string can contain pretty much anything. So letters, numbers, symbols, anything you want. Integers, which are just numbers, and Booleans, so true or false. So in Python, if you want to declare a variable, you can, in the first part, you write the name of this like container. So what you want to call it. So here we have my first integer, and this will be the name of the box, so to speak, where we're gonna store something. And then after the equal sign is where we specify the data that we want to store with that name. So here we have my first integer equals 5. So we can refer to this value later on by using just my first integer. And this is helpful so that you know what each thing is representing, and you don't have just a bunch of numbers floating around your program. Here we have an integer in the first case, and in my first string we have a string. So to declare a string here, you have to use the single or double quotes, and inside you can just type whatever you want. So you could have symbols, numbers, pretty much anything except the quote, because it shows you where the string ends. And in Python, you can show these values when you run your program using print. And print is a function. We'll cover later on how to define our own functions. And print will simply display whatever thing you pass. So in this case, we have print my first integer, which we know it's equal to 5. And then we have my first string equals hello world. So the second print statement will print hello world. And the good thing with the format we're using for these sessions is that you can run the code as you see in these examples. So if you click in the play button, you'll get an alert, and you can press run anyway. And you can see the result of the code you have in this cell. So here we see 5 and hello world, which is what we defined before. And you can think of this program as something like this. So when Python is reading a program, it sees my first integer, and we know it's assigned to 5. So it gets the data and prints that. And I'll also zoom in a bit because I think the font is quite small. Hopefully this is better. And so in the second example, we have pretty much the same thing, but with the other variable. Okay. I will release a question now on the item pool, and this will be a multiple choice question where I'll ask you to pick which of the variables that are shown are valid. This is something I haven't specified yet, but we'll give it a try. So we have 5 variables there. Each one of them has a different type. We have an integer and a few strings. And some of them might start with numbers, and the other ones are just letters. So I want you to pick the assignments that you think are valid in Python.
I think that there's someone with their mic unmuted.
Oh,
Do you guys want to make sure your mic's muted? Thank you. Nice.
so we still have a few people answering. This is anonymous, so you don't need to be worried about getting the right or wrong answer. We still have answers coming. And I'll release the answers now. So quite a lot of people got the two correct variables right. Now I'll go through each one of them and explain why they're not valid. So option A, where we have a dash and then my variable equals 9, it's invalid because in Python, a variable must start with a letter. Although you can have numbers and underscores afterwards, you can start it with a number or with the dash in this case. So this option is not valid. Option B, we have letters and then a string afterwards, so this is perfectly fine. Option C is the same problem as A, so we start the variable name with numbers, which is not valid in Python. Option D, we only have numbers, no letters afterwards. And we know we can also start with numbers, so this is not valid. And lastly, we have option E with Y118, and this is valid because we have a few letters to start with, and then some numbers at the end. And afterwards, we just have a string saying an introduction to Python. So just to recap, a string can have the name of a variable can have letters and numbers and underscores, but you must start with a letter, even if it's just the first character. There's another type of data we can store in variables, and they're called Booleans, and they're used to represent true or false. And this is named after George Boole, who first defined an algebraic system of logic in the mid-19th century. And in Python, if you want to store this value true, so this is different from a string. It shows that something will be true. You write true with the uppercase T, and for false, the same thing but with an uppercase F. And we will see why this is useful later on. And I'll release another question about Booleans. So we know that variables have different types, and each type has a different way of being declared. We know that Booleans are declared with the uppercase T and F, and a Boolean can only be either true or false. So I'm just waiting for the answers now on the item poll. If you don't have it open yet, you can answer the live questions I'm releasing. I'll release the answers. So in this case, we only have one valid Boolean declared, which is option D. So option A is not a valid Boolean because it's only a string. Even though we wrote true inside, we started it with the assignment of this variable with the quotes. So this is a string, not a Boolean. Option B, it's close, but the t is lowercase. So this wouldn't be a valid Boolean. Python in this case would think that you're trying to find, to assign the value of some variable named true to your new variable called my_variable. So this is also not a Boolean. Option C, we have the same case as option A, but with false instead. This is also not a Boolean, it's a string. Option D is correct. So we have an uppercase T and true. Option E is not correct because the F is lowercase. So this would be you trying to assign the value of some variable called false to a new variable called my_variable. And lastly, we have my variable equals 1, and this is an integer and not a Boolean. So it's another type. Python also has a few operators which are useful when you're dealing with different types. We have addition, which is just a plus sign. We have division, and we use the /. We have subtraction, which is just the dash. Power, so if you want to write 2 to the power of 2, you'd write 2, then the 2 asterisks, and your power afterwards. And finally, we have the modulo, which is, it gives you the remainder when you try to divide two numbers. So if you look at the example we have here with 13 and 5, the result of this operation would be the remainder when you divide 13 and 5. X is just, we're adding 2 plus 2, which we know it's 4. And also note that if you use parentheses, they take precedence over the next operator. So Python will add the two numbers here, and only after that will it try to divide by 4. So X would be 1 here. Y is 10 minus 5, which is 5, and we have the parentheses again. So it takes precedence over the power operator. And here we're just doing 5 to the power of 2, which is 25. And if you click here on the cell thing, you can see the result we expected. So 1 4 divided by 4. The 5 to the power of 2 is 25. And the remainder of the division between 3 and 5. Although these operators may seem specific for dealing with numbers, you can actually use them for other types. And you can use them, for example, if you want to join two strings. So here we have hello assigned to A and world assigned to B. And inside the print statement, we're trying to add the two strings, which might seem a bit counterintuitive, but you're joining the two strings and forming something new. So A plus B would be hello world without the space in between. So if you run the code cell, you get hello world. There are other cases where you can use some of these operators with strings, and one of them I'll release now in the item pool. In this case, we have test. We have the asterisk, which is used for multiplication in Python, which for some reason seems to be missing from the arithmetic operators. But it's just the normal multiplication. And we're multiplying test and trying to print the result of that operation. There are a few options for what do you think it might output when you run this program.
Yeah. Bro, Ben is showing me.
We have 8 answers. So we want the output of test multiplied by 3. This might be slightly confusing because you have a string multiplied by a number. So what does this actually mean? I think we have quite a few answers. I'll release the answer now. Basically, if you try to multiply a string by a number, this will repeat the string you're trying to multiply by that number of times. So you have test multiplied by 3. And what this does is make a new string with test repeated 3 times. So if you try running it on the cell, you can edit this. You get test, 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 and you could have something else. It will just repeat that string that many times. You could even have 10 times, whatever. It will just repeat the string. In the next part, we have an exercise, which should be fairly straightforward after what we've covered so far. And if you try running this, you've seen that you have no spaces in between hello and world. So I want you to edit this code cell and modify this code so that when you run it, you have a space in between hello and world. And once you've done that, just submit your answer on item pool. You can copy and paste. There's actually more than one way of doing this, but they should all result in the same output. It's quite quick, so I'll reveal the answer now. So I can see your answers, and I think most people got it right. So there's more than one way you can do this. The first one is just by adding a space in the first variable, and when you join them, you'll get hello world with this space. You could also do something like this with a space on the other variable. You could print directly the string you want, and you could also add another plus sign with the space that you want in between, and this will print the string we wanted in this exercise. But what if we want to print a string and a number at the same time? So if you're making maybe a program that calculates the sum of some numbers the user has entered, and you want to print the total. If we try to, for example, total equals 100, and your total, and if we try to add the string with the number, this won't actually work because we know that total is of type integer, it's a number, and we have a string. So Python doesn't know how to join these two different types together. And what you need to do is change total to be a string, because we already know that Python knows how to join strings. So if you use the string function, this will create, we'll get the number and we'll transform it into a string. And in general in Python, to call a function such as string, or str in this case, you have the name, and then in between the parentheses, you put the data that you want to give that function. We'll cover this in more detail in a bit, but just for this example, we have this function string with the number 100, and we change it to a string, and then if we try and run it, now Python knows how to join these two together. For next exercise, this is inspired by the sort of final project you'll be doing in this course. So we have some cells and they feed on food. And in the beginning, we want to add a certain number of food with a certain energy to our simulation. So here we have two variables. We have num_food, and it's equal to input. So here we're calling a function called input. And what this function does is it prints whatever you give it. So we have enter number of food, and it will wait until the user types something and presses enter. And in the second line, we have the same thing. So we have energy equals input, and then enter food energy. And so it will print this, and once the user enters a number and presses enter, it will store that in the energy variable. So what I want you to do is complete this program so that when you run it, it asks the user for these two numbers and prints adding 35 food with energy 20. And once you've done that, you can paste the code again on item pool, and then we'll review your answers. So you already have the code to get the numbers or the input from the user. The last thing you need to do is print the result. we have 4 answers. So you pretty much only need to write the last line. And what you need to do is join these strings with what you want to print. So you just call print adding, and then we want to show the number of food. So we just use this variable, and then food with energy, and then the energy the user typed. Exclamation mark. So you're just joining the user input with something that's already predefined. And if you try and run this, we get the space. We get the correct output. In Python, there are also assignment operators, and they're a shorthand for some operations. So we have a equals 6 and a equals a divided by 2. So if we wanted to divide the number we already have stored and store it in the same place again, instead of typing a again and divide by 2, we can use the division operator and an equal sign right afterwards, and the number we want to divide b by. And this is the same thing as we have above, but it's short and makes our code a bit more clean. So if we try and print b, we should get the same thing. So we get 3 and 3, and we can also do this for other operators. We can do it with the plus sign. So to sum something and store it in the same place, we can use the subtraction. So subtract something and store it in the same place. And we can also use the other operators we learned before, the multiplication operator, power, modulus, and you can continue to use other operators even if you're using this new type of assignment. So without running the code, I want you to try and guess what the output of this program will be, taking into account what we've learned before. So we know that this will, for the first case, this will multiply the number we have stored by something. And the other examples are similar. So we want the output of this full program. So we're printing 3 things. So we know there will be 3 numbers. But after we assign the initial value, we're performing some operations that change what value is being stored there. I'll wait another minute or so for more answers. Yeah, so the correct option was option B. In the first case, we're just multiplying 1, 2, 3, 4, 5 by 2, and we saw that in A, and that's 24,690. In the second case, we have B equals 2, and then we use the power operator with 6. So we want to compute the power, the 6th power of 2, which is 64. The last one, we have two variables involved, C equals 10 and D equals 7. First, we calculate the remainder of 7 divided by 5, which we know is 2. And then we want to add to the variable C, so 210, 100 divided by D, which we know is 2. So this is 10 plus 50, which is just 60. We also have comparison operators. And this is where the Booleans we learned before will come in handy. So if we want to compare if two things are equal, we use two equal signs. So one equal sign creates a new variable, and two equal signs compares two values, and will be either true or false. So in this code, we have enter a number and print number equals 1. And this expression here, number equals 1, is a Boolean, and it will be either true or false. And if we try and run this, and you press 1, we get false, which seems wrong because we've entered number 1. But this is actually because it also compares them if the variables are of the same type. And 1 here, when it's read by the input function, it's a string. And when we compare here, we have this expression with the 1 in the quotes to show that it's a string. And we're comparing it with the number 1. So these are different things, even though as humans we probably think they're the same. This is why we get false when we print a result. And if we wanted to actually compare numbers, we could use a similar function to the one we saw before with strings. But instead of str to get a string, we're using int, which will give us the corresponding number. And what this does is it will convert the number we entered to something of the integer type, and we'll end up having 1 equals 1. They're of the same type, and they're also the same number, so Python will print true. I'll replace this. So if you type 1, you get true. So we've done this. And there are also other operators you can use to compare variables or objects. We have the closing angle bracket for greater than comparisons. So if you want to compare if a number is greater than another one. We have the opening angle bracket, which is less than. And we can combine these two with the equal sign to include. So if we want a number greater than or equal to something, we place an equal sign afterwards. And if you want less than or equal to, you just place the equal sign again, but on the less than operator. So here we have x equals 10, y equals 10. We know in the first case that they're both the same, so this just prints true. In the second case, we're checking if they're different. So in programming, in most programming languages, the exclamation sign is used to express the negation of something. So you're basically saying not equal. So if you read the exclamation sign is not, this is x not equal to y. and we know they're equal, so this is false. And then we have y greater than 10. We know this is false because 10 is not greater than 10, it's equal. And finally, x is greater than or equal to 10, which we know it's true because they're the same number. We'll be moving on to functions now. And functions will be really useful if you want to make meaningful programs that are well structured. We've seen some of them already. The functions we've seen are the ones that come with the Python standard library. So you don't need to define them yourself. They're ready for you to use. So print, we know it's used to display something when we run our program. We have input to get something from the user. We have int to convert to integer, and str to convert something to a string. But if we want to make something of our own for some specific purpose, we can actually define our own functions. And this can be done using the keyword def. So we start with def, a space, and then we need a name for a function. So similar to how we assigned names to numbers and booleans, we're associating some name with some function. So here we have def my function, and after that you need braces, and inside you can use this to have some parameters, which we'll see next. But in this case, we don't need anything. We just want to print hello, I'm a function. And also note that Python is very picky with indentation. So the body of the function, where you define what this function does, needs to be either two spaces indented or a tab. I think Google Colab converts the tab to two spaces automatically. So it should be pretty similar. So if you want to print something else, it needs to be on the same indentation level as the other one. So if we add something else. And then if we want to use this function, we write the name, which is my function. And we also need to put the braces in to show that we're calling this. And if we run it, Python will go to this definition and execute the code we have inside. Now we can see why the brackets are useful. So we have a and b, and these are the parameters of our function. And there's something we can give the function to do something. In this case, we have print hello, I'm in a function. And then we have print a and b. And a is the first parameter, b is the second. So if you call the function as we've seen before with the two arguments, which must be separated by a comma. So if you had a, b, c, you would just add another comma and the other parameter. And also note that they should be in order. So the first one will correspond to A, second one B, and the other one C. And here C doesn't actually do anything, but so you could remove it. So if you run this with the incorrect number of arguments, you get an error because this function only takes two things. So I'll remove this. And if we run it, we get hello, I'm in a function, and then argument 1, which is A, and argument 2, which is B. And functions are not only used to execute something. So here we're only executing something. We're not returning anything, but we can do that. So if you want to have something that calculates an average of two numbers, you could have A and B, the two numbers you want to find the average of. And then you can also declare variables inside, as you've seen before. And this variable is only accessible within the find average function. So if you were to try and write print total outside the function, so without the two spaces before, Python doesn't know what total is here because it's in a different context where there's no total variable. So we sum the two numbers and then we divide them by 2, but we use the return keyword to say that the function finishes here and we want to return whatever this is, which in this case is just the average. So we have these two numbers, Python will sum them and divide them by 2. And so if you were to call it like this wouldn't do anything. It would divide the numbers by 2, the sum of the numbers by 2, but you're not storing the result anywhere. So you can either assign it to something. In this case, we have the average variable and print it, or you could also print it. So you could pass it to another function because it will simply be another value as if it were some variable you've declared. So you get the same thing. So for our last two exercises, I want you to first write a function is greater than, which will take two numbers, a and b, so two parameters like we had before. And we want to return a Boolean value, which specifies whether a is greater than b. So we want to return something and do some comparison using the operators we've seen before. So I'll release the question. I'll just skip the other ones. And once you've done exercise 5, just submit your answer, and then I'll write the code for this function. So we have a function is greater than that takes two numbers. We want to return a Boolean, so it has to be either true or false. And we also need to do a comparison. So while I'm waiting for more answers, the good thing with functions is that you avoid repeating the same code. So if average is quite a simple function, but imagine you had 10 lines that are needed to compute the average of some numbers. Instead of typing those 10 lines every time you want to find an average, you can just say find average, give it two numbers, and it's one line only. So you type around 12 lines of code instead of 20 or so. And this also makes your code better because if something changes later on, you only need to change things in one place. So if the average now needs to maybe compare something first, we can change it here in this function, and that's it. We don't need to do anything else. Whereas if you had the same 10 lines repeated over and over, you'd have to go everywhere where you have those 10 lines, change something, and then you could forget and maybe your program wouldn't function correctly. We have 5 answers. I'll wait another minute or so. Right. So I'll walk through the code now. We want to define the function, so we use the def keyword, which stands for definition. We have the name of our function, which is it's greater than. And we know that we want two numbers to be compared. And we also need the colon at the end. And now we need to compare them. If you look at the find average function, we're assigning something to a variable and then returning it. But you can do this directly. So you could either do just this, and Python will compare the two numbers, and that value is returned directly. And you could have some variable with this comparison stored in, and then return test. But this is not necessary. You can just return it directly. So if we test this now with 2.5, we get false, which is right. 6 and 5, we get true. And for last question today, I want you to write a function that, given the coordinates of 2 points, returns the distance between them. So it takes 4 parameters. We have the x-coordinate of the first point, we have the y-coordinate of the point, and the coordinates of the other point. And we have the formula here, and in Python, it comes with a square root function included, and this is how we import it. You don't need to worry about it for now. But after we have this line, it means you can use the square root function as you would use any other function in your program. And we also know how to compute the power of some numbers and how to sum and subtract them. So yeah, we have to write this function, and I'll give you a few minutes again to write it. Um, does anyone have any questions? I saw that there's no answer so far. So is there anything that doesn't make sense with the exercise? Oh, um, Okay, that's interesting. Maybe try refreshing the page. Okay, nice.